Hello class, today we are going to move on to chapter 6 in macroeconomic section. So last time we talked about inflation, and I'm going to cover first part of the chapter 6 today on wages and unemployment. I would actually cover the labor market part first, and then the unemployment part I will cover in the second half of the lecture, which will be another day. Let's look at the supply and demand. Remember that when we talk about supply and demand, we do a lot of graph in chapter 3, earlier in the microeconomic section. So now we're moving on to the labor market now. And you remember in one of my introduction lectures on macroeconomics that I did mention that this demand and supply, the fundamentals are so important that it can apply to so many markets. So like in chapter 3, we cover the pizza market and product and services. So that's a product market. And so now we're going to cover the labor market. We're going to talk about its demand and supply. The fundamentals are very similar. And because the determinants of the demand side and supply side are very different. So you want to make sure you're not mixing them up. And then later on, we apply the concept of supply and demand to capital market and money market as well. So here it is. So first we look at the supply side, well, the demand side. The demand of labor. So this is your LD, which is demand for labor market. It depends on two things, according to this first slide we're looking at. Number one, it depends on productivity of the workers. Number one, it depends on the price of the workers' output. So what they're producing. So here's your L, which is your graph, right? Your vertical and your horizontal axis. And on your vertical axis is always your value, the number. So in this case are the wages, okay, which is in dollar value. And down here you have employment, or you could put numbers of workers. So this is the kind of thing that you want to take note. When I draw the graph on the whiteboard, I encourage you to do the same by taking note and draw it with me. So the labor market, again, depends on two things. Number one is productivity of the worker. So again, this is on the demand side. Do not get the two confused. We're only talking about the demand side. Number two is on the price of output. Okay, very important. It is the price of output, not the price of input. So it turns out that later on you could write down this equation, VMP equals to MP times P. VMP stands for value of the marginal productivity. And MP stands for your marginal productivity. And which is typically this one here. And then your P is the price of output. I hope you write this down, which will be your number 2. This is, sorry about handwriting, but that's price of the output here. Let me rewrite this a little bit better for you. Price of output here. Okay, so in other words, these two things determine the demand of labor. Depends on so let me give some example here. Let's just say, now remember the demand for labor are your employees. They're the one who wants your services, your work. And we are the worker, we are the supply side. We are the one who avail ourselves to work. So if you look at it, right, let's call this point A, and let's say this is 50K, 50,000 per year, something like that. So if it is say $50,000 per year that the employees have to hire their workers, they might hire say 7 workers, okay? But if it is lower, moving from point A to point B, so let's say this becomes 40K, okay? Then, you know, it's cheaper now. Excuse me, okay. Yeah, that's a demand for, oh yeah, sorry. That makes sense. I mean to put 60K, yeah. So because this is higher, yeah. So if it is 60K per year that they have to hire workers, in other words, it becomes more expensive for the employers to hire workers. Do you think they will hire more or less workers versus when it was 50K per year? The answer is less workers. Because, you know, I mean, before, if it is 50K you're willing to hire, you as employers are willing to hire 7 workers. Now it's more expensive. 60K you have to pay each workers per year. So of course you hire less. Okay, so what does it mean? From point A to point B, you could say that, oh, so as wages goes up, the number of workers hired comes down. So in other words, this is a negative relationship between wages and the number of workers that are being hired, or employment. And the vice versa is true. You can think about it as if you are, well, okay, let's not mention it, because when we get the supply side, I'll mention it. So for now, just remember the demand side. Okay, demands of labor. So in other words, nothing has changed. If you look at your fundamentals of demand and supply curve, your demand curve for product is still downward sloping. So just like in the labor market, this is still downward sloping. Okay? So remember once again, repeating here, the demand for labor depends on 2 things: how productive the workers are. Number 2, the price of the workers' output. You can think about it that way. If workers are more productive, you tend to want to hire more of them. Right? Yeah. So now, if the price of the workers' outputs are more worth it, like say if you're producing computers, the price of computers have gone up, so you want to make more of it. If you want to make more computers, you have to hire more workers. Okay, so that means everything will shift. Labor demand curve will shift to the right if 1 or 2 happens, or it could be a combination of 2. But to make it simple, 1 at a time. So again, what I'm trying to say here is make sure you know the difference between movement along a demand curve from point A to point B due to its own price change. So in this case, it's from 50K to 60K, so therefore the number of workers dropped from 7 to 5. But, which we have not mentioned it, but if any of those 2 factors change, productivity of workers or price of output change, it will not be a movement along the labor demand curve. It will be a shift from the left here, from this original graph, will shift to the right. So we'll look at that later. Okay, so next we're going to look at some example from a few tables. These tables are available in your textbook. So you need to pay extra attention when I mention this, because this is, we'll do the analysis together, and I'll ask you questions and make sure you understand this. Okay, so what we're going to do here is we got 4 columns here, and then we want to look at the hiring decision. Okay, we want to look at the computer companies known as Banana Computers. So he's got all this data here, and then he say the decision that the company has to make is how many workers should I hire? So let's look at it. So first column is the number of workers from 0 workers all the way to 8. Okay, And of course, if you hire more workers from 1 all the way to 8, you have to produce more computers, right? Makes sense. So if 1 worker can produce 25 computers, 2 workers can produce 48. 3 workers can produce 69. You notice that they're not proportional. Never mind about that, these numbers are given to you. They are increasing as you hire more workers, it makes sense. To what extent it is increased, how many percent are there? We're not going to get into that. So just take the number as given for now, okay? The next column, excuse me, column 3 is referring to marginal productivity of the workers, okay? So the first one, you have 25, and then 23, 21, and you notice that the numbers are coming down. So how do we get that number? Okay, in order to calculate the marginal values, remember your very first lecture, chapter 1 in the microeconomics section, Thinking Like an Economist, we show you how to calculate the marginal value. I'll give it to you one more time here. So if you were to calculate the marginal productivity of the first worker, you would take the total productivity of 1 workers minus total productivity of 0 workers. Well, in this case, total productivity, when you hire 1 worker, they will produce 25. So this is TP1 is 25, this is 0. So the answer is 25, okay? So, because the total productivity of hiring 0 workers is 0, you don't have anything there. So in fact, you notice that that 25 should be between 1 and 0. So next, if you look at the marginal productivity of the second worker, not 2 workers, but second workers, then the equation will be taking the total productivity of 2 workers minus total productivity of 1 workers. Okay, let's see if you could tell me the number. So, well, that's how we got that 25 right there, excuse me. Let me go back. I think I was pointing at the wrong thing, wrong figures there. So total productivity of 1 worker would be 25. Total productivity of 0 worker would be 0. So 25 minus 0 is 25. That's how you got that first 25 marginal productivity of 1 worker's year is 25. So you notice that 25 is between these 2 lines here, because that's how you derive it. You need the 2 sets of number to get that final sets of number. So finally, the second workers, marginal productivity of the second workers, according to that equation, and so on and so forth. Why don't I just go ahead and write this now, and then we'll work out the number here. So marginal productivity of third worker will be TP3 minus TP2 equals to so on and so forth. So I think you can almost do it now. MP4 will be TP4 minus TP3, like that. So let's do the second one, TP2 minus TP1. So if you were to hire the second workers, the total productivity of 2 workers would be 48. Total productivity of 1 worker would be 25. So that would be 48 minus 25, which is 23. And that's how we got that second set of number. So by now you should get it. So let's do the third one yourself. Total marginal productivity of third worker will be 69. Total productivity of 3 workers minus total productivity of 2 workers. So 69 minus 48, which is 21. Okay? So the last one, I mean, you could go on, but I'm just going to stop here. So that's how you get it, yeah. So like, for example, the last one, you got 11 because the marginal productivity of the 8th worker, 1, 2, 3, 4, 5, 6, 7, 8. So marginal productivity of the 8 workers is derived by taking total productivity of 8 workers, which is 144, minus total productivity of 7 workers. 144 minus 133 gives you 11. So that's how you get it. So I'm skipping some of them, but I think you get the idea. If you could always go back, right, rewind the tape so you could see it, yeah. So now the last column there, the VMP, the so-called value of the marginal productivity, is calculated by taking this equation, which I wrote down earlier. Now we need it now. VMP equals MP times P. So the value of the marginal productivity really is to take marginal productivity of each level times the price of the output. So the price of the output is given as the price of the computer, because this is what the workers are producing. The inputs are the workers. The outputs are the computers, because that's what they do. They produce computers. Okay, so you take the price of the computer, which is $3,000 per computer. I know that's kind of expensive, but that was back in year 2000. It's probably the mainframe computer. So 3,000, take 3,000 times 25, you get 75,000. Take 3,000 times 23, you get 69,000, and so on and so forth. So the last one, take 3,000 times 11, you get 33,000, 33K. Okay, so you derive that last column by taking 3,000 multiplied by each set of number at each level of workers you hire to derive that whole last set. And so far, so good. So what else? So one thing you notice is 2 points here. The first point is that marginal productivity decreases 25 all the way to 11 as you hire more workers. This is something known as a law of diminishing returns, which I'm trying to remember if we covered it in the microeconomics section, because this section is more like a microeconomic concept, although we are dealing with the macroeconomic section of the course. So here it is, you have this equation, value of the marginal productivity equals price times marginal productivity, which is the same as this equation you see up here. Okay, so now, so far so good, we got that last column. So the next thing is, we haven't solved the problem yet. We just lay out all the numbers here, and then we say, okay, the next thing we want to do is remember a decision making here is for the banana computers company to decide how many workers should they hire. So what is the optimal number of workers they should hire? How would they solve this problem? So they have to use something called hiring rule. I hope you could see the PowerPoint slides here. So the hiring rules say we will hire up to the point where your value of the marginal productivity of the workers is greater than their wages. I don't know if you get it, but let me go ahead and write this down right here in blue. So our hiring rule says that you will hire if the value of the marginal productivity is greater than or equal to, I think the equal sign should be there, but that's okay. You could read this and take notes, the wages. So this is sort of saying, we talk about, is it worth it to hire another worker? How do you measure the worthiness of the workers? What is worth it? One way to measure it is look at their wages, and look at what is their productivity, their marginal productivity. Is that higher than their wages? If it is higher than their wages, yes, it's worth it, we should hire them. But if the VMP, your marginal productivity, is below the wages, you say, it's not quite worth it, so maybe we shouldn't hire. So the last unit we should hire is when they are equal. So that's a benchmark there. So using this particular benchmark here, where VMP is greater than or equal to wages, we can now solve the problem, the decision making. How many workers should we hire? So this is what we do. So I hope you can see these 2 lines here. It says, we're making 2 assumptions here. So economics is about making assumptions a lot of time. So the first assumption we make is, what if the wages is 60,000? How many workers would you hire? So what you do is you say the wage, the W is 60. Let me go ahead and write this down. So if it is 60K, you want to make sure that it fulfill this law, must be greater than wages. So you look at all this number, is 60K greater than, the wages is, whoops, got it wrong. The wages is on the right hand side. So this is your 60K. So if this 60K, you want to hire, how many would you hire? So you look at this number here. So all these are above 60K, right? Keep going up, and what about this one? So everything so far so good, because all this VMP up to this point are higher than 60K. Well, when you get to this 63K, you say, whoops, this is where I should stop, because then it no longer applies. So if you stop somewhere here, you go back and count. So then that's 3 workers. So then you hire 3 workers. Now what if it is lower? Remember we say earlier, if it is lower, you will hire more, because it's cheaper for the firm to hire more workers. So if I erase this, if it is 50K, so actually I'm going to change this number here. 60K, we will hire 3 workers. I'm going to put 3 here. I'm going to use the same number as this. So if it is 50K, how many would you hire? Okay, that one I don't know. So if it is 50K now, you go back and say, yeah, this is okay. Well, no, actually this is not okay. You stop right here, because 50 is between 45 to 51 here. So you stop right here, you go back and count 1, 2, 3, 4, 5. So you will end up hiring 5 workers if it is 50K. If it is cheaper to hire, you hire more. So this is a case where you actually reverse from 3 to 5 workers. Right, so if it is cheaper to hire, if it's cheaper to hire from 60K to 50K, then you will end up hiring more workers. Okay, so that's what it is. So if 60K, you hire 3 workers, that's point B. And if it is 50K, you hire 5 workers. So it's moving from, well, we should say then this becomes your point A, this becomes your point B. So it moved this direction, from point A to point B. Banana company or computer company will hire more workers at lower wages. So we talked about that earlier. Very important, because of the law demand say, if it is cheaper to hire, then you will hire more. Makes sense. Okay, so in other words, the wages and the employment are inversely or negatively related. One up, the other one down. Which one up? The wages up, workers higher down, and vice versa. And of course, we know what is vice versa. Vice versa, if you explicitly state it out, it will mean as wages come down, number of workers higher will go up the other way. Okay? So, which is the case right here. Okay, so now the textbook will not show you, but this. Okay, let's look at this. The lower the wages, the greater the number of workers higher, as you already know. But the textbook does not show you moving from one point to another, but my graph here does show you clearly. So the wages can be measured in nominal or real terms. All this is saying is that the demand curve is downward sloping, because the y-axis, the value of the y-axis, which is wages, are negatively related to employment. What does that mean? The lower the wages, you hire more. The higher the wages, you hire less. Okay, next, we want to look at the shift in demand for labor. I think I mentioned that earlier, that if you shift the labor demand curve, it would be because due to one of those two factors. So the first factor is productivity of the worker. So let's look at another example. And then the productivity of the worker is the first factor. The second factor is the price of the company's output, which in this case is the price of the computers. So let's look at one more example here. Now in this example, the first four columns you see here are the same as the previous slide. You could look at your book as well. The value of the marginal productivity in the last column here, the fifth column, 1, 2, 3, 4, 5. Now these sets of numbers are different than these sets of numbers. The reason is because, let's read the title. What does the title say? Well, the title say production and marginal product for banana computer after an increase in computer prices. Oh, so that's what happened. Okay, instead of computer prices being 3,000 per piece, now they're going to increase it to, what's the number? 5,000 per piece. Okay? So now, before we even look at a number, let's think about it conceptually, in terms of theory. So if the price of computer goes up, yeah, they have to make more, they have to hire more workers. So we expect the demand for labor curve line to be shifting to the right. Because to the right is when you have more workers, given the same wage rate. Oh, wage level, excuse me. Yeah, so that's what happened. So now you could see that, what is the assumption here? So this is a case where we have the previous slides where if the price is 3,000, 60K, you hire 3, 50K, you hire 5. So that's the previous case. I represent it so it's clear for you to do the comparison. So now, that last column is say 5,000 per computer. So you take 5,000 multiplied by the same marginal productivity because we haven't changed anything here. The number of computers produced by the workers are the same. Marginal productivity is the same. The value of the marginal productivity, the only thing difference are these two columns here. This column say if the computer price is 3,000. This column say if the computer price is 5,000. Okay, so in order to get the value of the marginal productivity, we know that if marginal productivity stays the same but price has gone up, the VMP has to go up. So indeed, so how do we know? So we take 5,000 times 25. If you have your calculator, you can do that. You get 125K. So jump down to 11 times 5,000, you get 55K. So in other words, you derive another set some number for that last column here. And if you look at it, everything is higher than what's in the same amount of workers you hire, same marginal productivity, but the price of computer has gone up. So this number consistently are higher than this number, 75K, 45K, 65, 30. So that's the observation you make. Okay, so how many workers would you hire now if the computer price had gone up? You expect to be higher throughout every level. So once again, if the price is 5,000 compared to before, if the real wages are 60K at the beginning, so again you compare 60K, this is greater than 60, let's see, if it is 60K, if the wage rate is 60K, is anything higher than that? Yes. Right here. Okay? So now you can only hire this up to, up to this point because VMP is still greater than 60K. But below this, and this is no good, okay, because then you violate that principle. So you stop right there, you count 1, 2, 3, 4, 5, 6, 7. So you hire 7 workers if it is 60K. Now if it is lower, as I said so many times here, if it's lower, you hire more. How many more? Turns out that it's only one more, which is 8 workers, from 7 to 8. So 65K. Now, if it is 50K, you would say, oh yeah, this one would still cover that last one. So you hire one more workers. And so count backward, 1, 2, 3, 4, 5, 6, 7, 8, so you hire 8 workers. So here it is, if wages is 60K, you hire 7. So 7 will be somewhere here. So then this goes up here. This will be your A prime. And then you have 8 workers somewhere here. So this will go up here. This is your B prime. So then you derive another line like that. So I'll have to be out a little bit more. So you got 2 points here. If it's 60K, you hire 7. If it's 50K, you hire 8. So 2 points here, we call A prime and B prime, and then join these two together. So, right. So you could see that the labor demand curve shift to the right from LD to LD1, for example. Okay. So, there it is. If you increase the price of the workers' output, also increase. If you increase the price of the workers' output, that is the computer price, the demand for labor also will go up. So shift to the right due to the price of output goes up. Shift right. What shift right? Labor demand curve. You have to be specific here. Okay, now there is one more factor we have not talked about, that is productivity of the workers. So we also have to analyze that. In order to do that, so let's look at another example. So this will be another table in your textbook now. So if you look at it, this is the number of workers. This is computer produced per year. Notice that this time the worker is more productive now. Look at this first, one worker can now produce 37.5 computers instead of 25 computers. Hey, he's more productive now. Because we make that assumption, we say 50% increase in productivity for all the workers. Okay, the price remains the same of the computer. We go back to 3,000, the benchmark case, and now we recalculate everything. What do you mean by recalculate everything? So once again, you see that 37.5 is 50% higher than 25 computer. So this is all calculated for you. You don't have to worry about that. Just take the number as given. So now, in order to calculate marginal productivity, same thing. The marginal productivity of first worker is total productivity of 1 worker minus 0 worker. So 37.5 minus 0 is 37.5. So how do you get 34.5? You take 72, which is a marginal productivity of the second worker, is derived by taking the total productivity of 2 workers, which is 72, minus total productivity of 1 worker. So 72 minus 37.5 should give you 34.5. So you get the idea. So you derive that third column there. And finally, that last column, we go back to computer price being 3,000. So take 3,000 times marginal productivity for each worker. So you get this new set of numbers. And once you've done that, again, apply that hiring rule. If it is 60K, how many workers will I hire? By applying this hiring rule. So you look for 60K, where is it? 60K will be somewhere here, right? Between 58 to 67. So you draw a line here, you count backward, 1, 2, 3, 4, 5, 6. So if it's 60K, you hire 6. But if it is 50K lower, you want to hire more. So you could push 1 more This one is not okay because VMP is still higher than 50K, but not here. We draw a line here, count backward, 1, 2, 3, 4, 5, 6, 7, so 7. Okay, so you have to do one more, 6 and 7. As you can see, 6 will be somewhere here, 7 will be somewhere here. So in other words, it would still make them shift to the right. So which is a case of the demonstrating that second determinant for the rightward shift in labor demand curve due to higher productivity of workers. And if you think about it, it does make sense. If workers are more productive, look at today, we got computer, workers are more productive now. In the old days, you have a typewriter, so which one's faster? Which one say faster? I think computer does. Okay, so if you would agree, so then we got technology, times are better, so workers are more productive. So therefore, they will want to hire more workers. Because there's another flip side of it would be, if workers are more productive, they become more digital, or everything becomes automated, and you get rid of the workers, right? And the machine takes over, the computer takes over. So the computer can replace, or machine can replace the work of 10 workers, for example. So think about a tractor, right, with the 10 acres of land. Which one is faster? To get a tractor out in the 10 acres land, to plow the land, or get 10 workers out there to do it by hand? Tractor is faster. So yeah, if you automated, your work, then replace laborers. But that's kind of like slightly different flip side that we talk about here. So the main thing that we talk about here is labor demand goes up. Well, the demand for labor goes up if workers are more productive, or if the price of the output they produce are more expensive or higher. So here it is. So this is, if there's an increase in productivity of the workers, it also increase the value of the marginal productivity. So this would be the case at case 2, right? Marginal productivity goes up. Your price of the computer remains the same. We're not changing that, but you increase the marginal productivity of workers now. So therefore, if one stay put, the other one goes up, this is a product or multiplication, and VMP goes up. So VMP goes up means the value of the marginal productivity, or otherwise known as the labor demand curve, they are the same thing. We shift to the right, so indeed so. So if workers are more productive, the value of the marginal productivity goes up, then your bosses, your employers who want to hire more workers at any given wages, so therefore labor demand curve will shift to the right. So this is before and after. Before, you're right here. This is when one worker produces 25 computers. And this is after one worker can produce 37 and a half computers, 50% higher productivity. So it shifted to the right. And notice that this shift is due to one of these two factors, and this time it is the productivity of the workers, which will also say the MPs of the workers. So the MP here, this is your P here. So both cases will actually make the labor demand curve, or VMP, or labor demand curve shift right. So every time you shift something right to the right, what's on your x-axis, which is employment, will go up. So this is a case, and I think I'll stop here because that's the next time we will talk about the labor supply curve and the unemployment. So this is all that I talk about. So in summary, what I might only cover the labor demand side of it. And what are the two factors that determine the labor demand? One is the productivity of the workers, which we use marginal productivity to measure. How do we calculate marginal productivity? Here's how you do it. Take the total productivity of produced by two levels of workers. And then finally, the second determinant of labor demand curve change is the price of the output or price of the computer. And in both cases, they shift the demand curve for workers to the right. Now, if you're only talking about on the price increase or the wages go up or down from 50K to 60K per worker or per year, then you're only talking about movement along the demand curve, only from point A to point B. You're not shifting the graph. So remember that was a very important concept, distinction that you have to make between movement along the line, demand curve movement along the demand curve and the shift in the demand curve. That was one of the fundamental concepts that you have to be sure that you understand from chapter 3. So now we are repeating that concept again, except in this case we are applying to the labor market. Okay, that's all I have to say for today, and thank you for listening, and next time we'll get on to talk about the labor supply curve. Thank you.